Welcome to this explainer. Today, we're diving into a complete masterclass on what is actually hiding in our food. We're going to look at the whole picture here, from global supply chain vulnerabilities all the way down to the chemistry happening right on your very own kitchen counter. So, if you want to truly understand the food you're eating every day, consider this your essential teaching guide.
Okay, let's dive right into this with a question that might make you, well, a little uncomfortable. Is your milk actually milk? Or is it a carefully engineered chemical illusion? You see, food adulteration is no longer just about watering down a product to stretch a dollar. It's evolved. Today, it's a highly sophisticated deception, a deliberate degradation of food quality using some seriously advanced chemistry. Here is our syllabus for today's lesson. 1. What is food adulteration? 2. The prime targets. 3. The chemistry of deception. 4. Hidden health hazards. 5. High-tech lab detection. And finally, 6. Test your food at home. All right, kicking things off with Section 1. What exactly is food adulteration?
So, the main driving force behind most of this deception is a concept known as economically motivated adulteration, or EMA for short. Basically, this is the deliberate degradation of food quality strictly for financial gain. It happens when fraudsters add inferior, cheaper substances or completely remove the valuable ones just to lower their production costs. And honestly, whether it's diluting milk with water to bump up the volume or swapping out premium extra virgin olive oil for cheap, lower-grade olive pomace oil, the motivation is always the same: maximizing profit at the direct expense of public health.
Moving right along to Section 2, the prime targets. Now, what's really interesting about this is exactly why milk is such a massive target. You see, the quality and price of milk are graded using invisible surrogate parameters, specifically things like fat percentage, solids not fat, and protein content. Because buyers are testing for these specific parameters rather than looking at the milk itself as a whole, it makes it incredibly easy for fraudsters to fake these metrics using dangerous chemicals. They aren't actually trying to make milk, right? They're literally just trying to beat a specific test.
Spices are another huge one. Everyday commodities like turmeric and chili powder aren't just adulterated for weight, by bulking them up with inert things like sand or chalk powder. No, they are frequently targeted for intense color enhancement. Fraudsters use highly toxic synthetic dyes like Sudan red and chili powder, or metanel yellow and even heavy metals in turmeric, just to create those vivid colors that we, as consumers, naturally associate with freshness and high quality. Which brings us to Section 3. The chemistry of deception.
To really get this, we need to understand the Kjeldahl principle. Regulatory tests for protein in milk don't actually measure the protein directly. Instead, they measure the total nitrogen and just estimate the protein from that. And guys, this is a massive loophole. It means the test literally cannot distinguish between nitrogen naturally bound in authentic casein and whey proteins and nitrogen coming from literally any other source. Fraudsters exploit this by adding cheap, industrial nitrogen-rich chemicals. Take melamine, for example. It's a plastic used in laminates, flame retardants, and it is roughly 66% nitrogen by mass. Urea is around 46% nitrogen. By dumping these in, they artificially inflate the test results, passing off diluted water as premium, high-protein milk. So the crucial point here is that the chemistry of the adulterant is precisely matched to the deception required. Formaldehyde? That gets added to milk during long unrefrigerated transport because it cross-links proteins via methylene bridges. Basically, it acts as a powerful tissue fixative and preservative. Then you have synthetic detergents, like commercial-grade sulfonates. These are added to diluted milk because they lower surface tension, stabilizing oil and water emulsions to recreate a fake, foamy, quote-unquote creamy texture that completely tricks the eye. Next up, Section 4, hidden health hazards. The biological impacts of all this chemistry fall into a few distinct categories. Acutely, ingesting things like detergents disrupts your intestinal mucosal membranes, causing severe gastroenteritis and diarrhea. But the chronic risks? Those are even more terrifying. Melamine actually combines with cyanuric acid in your body to form insoluble crystals. These obstruct renal tubules and can lead to severe kidney failure. And those synthetic azo dyes we mentioned earlier? When they hit your gut and liver, your enzymes actually break apart those synthetic dyes, releasing chemicals known as aromatic amines, which are classified as highly probable human carcinogens. We also see specific outbreak syndromes. For instance, epidemic dropsy, which causes widespread edema and cardiac failure when mustard oil is adulterated with the toxic alkaloid sanguinarine found in arginine oil. And we've absolutely got to remember why this matters so deeply. These heavily adulterated, cheaper products almost always disproportionately end up in low-income communities. Vulnerable populations, especially pregnant women and children with developing bodies, face the absolute highest risk of physiological damage and toxic accumulation from these daily, low-dose chemical exposures. It is a serious public health crisis.
All right, let's look at how we're fighting back in Section 5, high-tech lab detection.
The evolution of our detection capabilities over the years has been truly staggering. We started way back with classical wet chemistry spot tests, simple color changes. Then we leveled up to advanced chromatography, like HPLC and GCMS. These are essentially incredibly complex chemical sorting machines that can separate and quantify specific small molecules. Today, we're using advanced nanomaterial biosensors. By using techniques like surface-enhanced Raman spectroscopy, or SIRS, we can now detect melamine in milk down to an incredible 0.05 parts per million. To put that into perspective, that is a wildly tiny needle in a very large haystack.
The cutting-edge future of food safety really relies on smart, connected networks. We are now integrating explainable AI, or XAI models, with Internet of Things sensors that can monitor real-time changes in volatile freshness indicators. Think things like amines in fish or ethylene gas in fruit. Explainable AI is absolutely crucial here because it allows the automated system to actually justify its safety decisions to regulators. Combine that with blockchain technology to secure end-to-end supply chain traceability, and we're building a net that is getting increasingly difficult for fraudsters to slip through.
Finally, Section 6, test your food at home. Let's start off by spotting the most common form of EMA, watering down milk. We can do this with a super simple physics-based experiment called the milk streak test. All you do is place a single drop of milk on a polished, slanted surface. Pure milk is going to flow slowly, leaving a distinct, visible white trail behind it. But milk that's been heavily diluted with water, that's going to flow down very fast, leaving little to no trail at all.
Next up, let's test for premium honey, which, as it turns out, is frequently substituted with cheap rice, corn, or barley syrups. For the honey water drop test, simply add 1 drop of your honey into a clear glass of water. Because of its specific density and composition, pure honey will settle right at the bottom of the glass without dissolving immediately. If the drop disperses and dissolves rapidly as it sinks, well, you're likely looking at sugar syrup adulteration.
And this brilliantly illustrates a slightly more advanced home chemistry test, the turmeric acid test. If you take a pinch of turmeric, put it in a test tube, and add a few drops of concentrated hydrochloric acid, you're actually testing for the presence of that illegal synthetic dye we mentioned, metanyl yellow. If the solution suddenly turns a vivid pink or magenta, unfortunately, that is a positive result. The underlying chemistry here relies on the acid reacting violently with the dye's molecular structure, causing an immediate, undeniable color shift. As we wrap up this masterclass, I want to leave you with one absolutely crucial thought. A negative home test is a fantastic first line of defense, right? It empowers you in your own kitchen. But remember, it does not guarantee the complete absence of chemically invisible adulterants, like low-level pesticides or heavy metals. Sophisticated food fraud still requires vigilant regulatory science and hard laboratory confirmation. But by understanding the chemistry of deception, you are now equipped to look at your next meal with both a curious mind and a cautious eye. Keep learning and stay safe out there, because before you sit down for your next meal, you really have to ask yourself, how well do you actually know what's on your plate?